Thank you for your interest in STAAD.Pro CONNECT Edition. This video is part of the series of excerpts from the Increase Your Digital Productivity with STAAD.Pro CONNECT Edition live event held at Bentley's Digital Advancement Academy located in Pune, India. This excerpt is titled IS 800-2007 Implementation in STAAD.Pro CONNECT Edition. The presenter is Bentley colleague Kaushal Agarwal, Technical Support Engineer, Structural Design Engineering Analysis.
Favorite question from the designer who is designing a steel with STAAD? Why there's a difference between the design results from Select Series 5 to Select Series 6? That's a favorite question. That's what we heard a lot more time when we are trying to support these STAAD.Pro applications at the back. So my session here will I'll try to cover as much as details on the steel design. What has actually we changed? What are the new specifications we have introduced? At which time actually we have introduced so that it is affecting our design. So that I think I'll try to cover as much as I can from this platform. So let's look at one by one these specifications. Mostly it has been affected by the amendment which actually came in 2012. Unfortunately, it's actually been implemented through the course of Select Series 6 implementation. The amendment which came in 2012 is actually been applied in Select Series 6 version in a series. So that's where it's actually affecting some of your designs when you are trying to compare the Select Series 5 design to Select Series 6 design. So I'll just try to make you understand what are the changes that we did. First of all, inside STAAD now we are conforming to the clause of 4.4 3.1 the IS 800-2007 which actually specifies clearly that if the moment amplification factors are more than 1.4, you probably should go ahead with the second order analysis. So you can see over there, and let me open a model where where I'll just try to show that how STAAD actually throws that warning to you, and how it can be simplified. So analysis methods. There we go with the first model. So it's already analyzed. I can go directly to the output, and in the output I can see I have effectively two warnings. One of the warning, so if I read the warning over here, it says that the value of the moment amplification factor ky and kz is greater than 1.4 for member number 1. So as per the section 4.4.2 of IS 800-2007, we need to actually confirm to the specification now or a second order analysis. Now it's really important whenever we do the second order analysis that we do not consider load combinations, but we consider the repeat load. So that's one of the other part. So if I analyze this model with a different analysis type, which I've defined here as P delta. So I'll just uncomment it and comment the perform analysis, which is just the static linear analysis. So you can see that I have added here a P delta analysis, and I'll save this file and rerun this again. So let me run it. And after running it, you can see that warning actually goes away and your steel design is perfect. So this is actually the first point where we did the change. That's number one. Let's look at some of the other parts. The second is actually from the clause 4.6 mentions about the buckling analysis. So, and you have here on the right the cutting actually I have taken from the code. So the code actually specifies either you should adopt an approximate method or go for a rational elastic buckling analysis. That's what the code specifies. Now on STAAD, actually you can do the rational elastic buckling analysis. I have an example for that as well. Let me open that and let's try to run that. So this example is having, if we look at the analysis procedure, you can see that this is having a perform analysis, buckling analysis. Okay, and we are performing buckling analysis over it. If I look at the output, I will see the output in the terms of eigensolutions. So these are the buckling factors which I'm getting over here. That is what has been asked by the code to check the criteria of buckling for whole of the frame, whether it is safe under buckling. So here I can see that under the modes, and I can generate modes. I think that has been covered by Sudeep in the first session. Then in the first session that we can do a rigorous analysis of the advanced buckling analysis using the STAAD.Pro Advanced, rather than just doing the first mode by devising the stiffness matrix. So it's a better approach to do the buckling analysis as far the STAAD Advanced is concerned. Oh, this is one of the important part, the slenderness check. So in the meanwhile, there was actually some releases regarding 20. There was a build number which is one of the build number which we have released for inside Select Series 6, that was 271145s. And before that build, this main and T main factor, if you even specify the -1 factor, it is not actually bypassing the slenderness check. That actually been corrected after that version. So the version after that, which is 45, that means the 20.07.11.82, or probably the latest Connect Edition, it is having the correct logic to bypass the check. You just need to specify main or T main factor as -1, and it will bypass the slenderness check. Now let me explain one of the other topic, which is modified logic for the slenderness check. Earlier, till the implementation of the version, I think 50, that actually 20.07.11.50, that was a build again from Select Series 5. In that, till that version, this slenderness check ratio actually become a part of the critical ratio. That means that let's say we run several checks for getting the combined interaction check or the critical ratio for a member design, right? And there are checks regarding the tension capacity, then there are checks regarding shear, bending, and then combined interaction check. And we get several different ratios. So till that version, which is, as I said, 50, till that version, what was happening is that slenderness ratio which we are getting after checking the slenderness check, that is also been considered into the overall check or overall critical ratio. So that ratio was considered, but actually what should have happened is that if the slenderness check is passed, if it is less than 1, then I should not consider that into should not account it into my critical ratios. Okay, so I have an example for it just to show you that what was happening before, what is happening now. I have one model here, which is I actually analyzed in that version where this logic was not implemented. So let's look at the output file. So if I zoom in a little bit, here you can see that the slenderness check has been happening over here, and the actual ratio is, of course, is more than the allowable ratio, which means that the slenderness ratio or slenderness check has not been passed. But if I look at the other checks in the summary over here, so I can see the ratios that all the checks actually here has been passed. Okay, so what should have been reported as in the critical ratio, as the overall critical ratio, is in this case where this ratio is more than 1, is that the critical condition will be slenderness. Okay, now as I said, what was happening before is that even if this slenderness ratio, in this case it is more than 1, but even if it is less than 1, so let's say if this factor would have come as 0.9, but all other factors at the bottom are, let's say, are lesser than that, even though it will report the critical ratio as 0.9. I think I make sense here, right? So that logic has been changed now. So logic is now that if the slenderness ratio is less than 1, so we will not consider that criteria into the overall shift effect, or I would say the overall, getting the critical ratio. So that actually can affect your designs. Definitely can affect your designs. Is, I think, the important part for you to understand. One more part which we have applied is in the clauses for 8.6.11 and 8.6.1.2 regarding the stiffeners. So there is a check that has been defined under the clauses for the minimum web thickness check, and if actually that check is not passed, I can provide some longitudinal stiffeners, or I can provide some the transverse stiffeners to actually to pass that particular check. We have introduced the LST parameter. So LST parameter stands for the longitudinal stiffeners, and I have 3 options to choose from: no longitudinal stiffener, or if I have a stiffener at 0.2D from the compressional flange. Okay, from the compressional flange, or the 2 stiffeners I have at 0.2 times of the depth, or 0.5 times of the depth. And for the transverse stiffeners, we have 2 parameters to define: TST parameter and TSP parameter. In case you want to consider the transverse stiffeners, TST parameters that I am actually providing the transverse stiffeners, and TSP parameter to define where you are providing those stiffeners, to actually define the spacing of it. Again, I have one more model to show where actually the check has been performed. So let me look at the output here. And I can see a warning here that minimum web thickness requirement for serviceability not achieved for member number 1. So this is a kind of a warning which I'll get after this implementation, that the web thickness requirement for serviceability is not met. The remedy, as I already told you, the remedy is to provide the stiffeners. So let me provide here some stiffeners. Let me go to the input file. So I have an LST parameter defined, or I can provide that particular factor from the GUI. So I will click on analysis and design over here. I will go for the steel and go for the defined parameters. Here I have the LST parameter, which is, as I said, the longitudinal stiffeners. I'll provide the stiffeners for at 2 locations, 0.2D and the 0.5D, and I'll just say I need to add this parameter. I need to first of all select the members. So LST parameter number 2 after the current, and I'll say assign and close. Let's run it again. This time I have no warnings. So if I look at the output file, so I have no warnings relating to the minimum web thickness check. So this is how it can be taken care if you want to provide those longitudinal stiffeners. Let me talk about the DBS parameter. Okay, so there was a parameter which actually existed in the first few releases of Select Series 6 that we call as the DBS parameter. So if you provide DBS parameter as 0, it will not perform the design block shear check. And if you provide as 1, it will actually perform the design block shear check. This actually has been deprecated from the version, as I said, the last release of Select Series 6 that has been deprecated. Apart from that, what we are trying, if you want to do this check, which is design block shear check, you need to define 4 parameters. Okay, so 4 parameters are ATG parameter, ATN parameter, AVG parameter, and AVN parameter. So these are the 4 parameters which are actually required. If you look at the equations, also these are actually the areas that are required to perform the the block shear check. So if I would have provided these check, STAAD will perform the block shear test check for you. So I have another example just to show you that how we can define that. So let me go through the block shear. If I go to design here, in the parameter blocks, what I can see is that I have assigned the the factors here. Hope you can see that the ATG, ATN, AVG, and AVN parameters. These are the factors. Actually, I have the parameters which I provided. And if I analyze this structure, I will be able to see in the output that under steel design, that actually it performs the block shear. This is the design force, and this is the capacity. So then only it will actually perform it. So DBS parameter is deprecated, but you need to provide 4 parameters to perform the block shear test. Check. This is one more update which we did. The implementation of clause 7.5.1, which is regarding the flexural torsion buckling strength of a single angle. So in the code, actually, it has been written that there can be 2 conditions where actually you are providing the load at the centroid location, or you are providing the load to an angle at one of the legs. So there is a parameter which has been provided. First of all, the A and G parameter. So A and G parameter 0 means, as you can see over your screens, is that it is actually the load is acting at the centroid, and if it is 1, that means that it is acting through one of the leg. Now, it should be associated with one of the other factor, which is fixity parameter, FXTY parameter, using which we can actually get from table 12 the K1, K2, and K3 parameters. You can see over this here. I need to calculate the lambda C inside STAAD, and for calculating the lambda C, I need 3 parameters, which I'll get from the table 12. And table 12 asks for whether your the angle is hinged or the fixed. So these are the conditions. These 2 parameters should be associated, then only this clause can be completed. So there is one more part, which is the reduced moment capacity calculation. So what our code actually defines, you can see on the right here, is that we have actually the reduction equation in the design capacity in case the value of n is greater than or equal to a. But what about the reverse? Do we have an equation where actually we can tell the reduced capacity in case the n is less than a? We do not have that kind of an equation, and that is actually giving me the reduced capacity to so much less in cases we have seen some of the cases where actually this exists, that this n value is less than a, where actually your reduced capacity is so much less that the design ratio goes infinity. So we have taken up with the code committee, and we are using the relevant clause from Eurocodes to take care of the situation. So this, of course, also can affect your design. So these are some of the situations which I'm discussing that actually can affect your designs. I need to tell here as well, the deflection values, if you provide, there are 3 parameters actually, can 0 parameter, can 1 parameter, and can 2 parameter. So the can 2 parameter is particularly for the simply supported beams. So in case of simply supported beams, earlier till the release of in the mid of Select Series 6, if you provide can 2 parameter for simply supported design, it is not performing deflection check correctly. It has been corrected in the version, as I said, the Select Series 6 last release of Select Series 6, it has been corrected. There is one more, these are the defects that has been fixed in the recent versions. Okay, and when you provide select command, instead of saying that code check, we can provide a select command, right? And if you provide a select command, the overall deflection check was also been done incorrectly. That has been corrected also. So this is something you should take care. This is something can affect your designs, as I said again and again. There's one more defect that has been fixed in case you provide the tubular sections from saying section database and define tube. The combined interaction check was not actually happening at all, and that actually is affecting your designs again. So these are some of the situations where probably which we are trying and tell you that the things that has been changed that is actually affecting your designs. So what is a recommendation from a Bentley colleague from Bentley side is that if at all you not able to move to Connect Edition, which is actually a recommendation, which is a total recommendation from our side to move to Connect Edition for a better better version, better design. But in case if at all it is not available, you should use the last release of Select Series 6, which is 271190. That is the last release of Select Series 6 that you should use for steel design as per IAS 800-2007 LSD code. That is the last version of Select Series 6, and of course I recommend everybody to please move to Connect Edition, for because as you can see, a lot of defects has been fixed, a lot of some of the enhancement that actually can affect my designs. So the logic has been corrected, some of the defect has been corrected.
This concludes this excerpt series from the Increase Your Digital Productivity with STAAD.Pro CONNECT Edition event. A playlist is included here containing all of the excerpt videos. Thank you for watching.